Hi everybody, my name's Cameron and today we're going to be looking at forces and pressure as well as density. We're going to be looking at pressure and surfaces, pressure in liquids, atmospheric pressure and flotation. Okay, so when I said pressure and surfaces, what am I talking about here exactly? Well, pressure is the force per unit of area. Okay, so pressure equals to force divided by area. Now, pressure is measured in pascals, and with that equation in mind, if we increase force, obviously we're going to increase the pressure. If we increase area, however, it's going to decrease the pressure because we are dividing that force by a bigger number. Same as if we had to decrease the area, we would be increasing the pressure. This is why something like knives, okay, the knife that you would use to cut things with, or scissors, okay, they have a fine point at the end. They are sharpened down to make that area of contact as small as possible so that it has the most pressure with the least amount of force. Okay. Alternatively, sometimes we wanted to have less pressure, something like skis. Okay, we don't go skiing with ice skating shoes. We go skiing with these broad, flat skis, okay, to increase as much area as we can so that the pressure on the snow is as little as possible while we can still go down it. Okay. Now, when we look at pressure on a liquid at rest, I guess, okay, it increases with the depth. And this makes sense. Okay, so the deeper you go under the water, the more actual water is above you. Okay, so if I had to take a liter of water and put it on your body, okay, on your chest, you're going to feel a liter of water. It's fine. If we had to go down a bit more, let's say 5 centimeters more, it might become 10 liters of water that's now above you. So that pressure is going to increase, you see. So that's why when we do the equation for pressure in a liquid, it's going to be equal to the density of the liquid multiplied by gravity, because that's what's pulling the liquid down, multiplied by height of how much of that liquid is above you. Okay, so it's also important to know that if the height, the gravity, and the pressure remain the same, it doesn't matter the shape of the container. Okay, so let's say you have a triangular container like this. The pressure over here, okay, would be the exact same as if the container was inverted and you were still sitting at that point. It's weird. You'd think that there's more water above you, but apparently not. Okay. And yeah, we can see this with this experiment. So if you put holes in different levels, the jet is going to be a lot harder at the bottom because of the increased pressure. Now, this isn't just for liquid. This is for anything really. We're talking about either a solid knife or we're talking about water. We can also talk about air. Okay. So atmospheric pressure is the thing. The higher up you go, the less your atmospheric pressure is, because you're going to have less air above you. Okay, so it's not that we're increasing our height from the ground upwards, it's that we're increasing the height of the beginning of our atmosphere going down, just like we would a glass of water. Okay, so again, height multiplied by the density of air, P, or just density, multiplied by gravity. So air molecules collide with surfaces to create pressure as well. Okay, so in a tube, let's say, or in a pressure cooker, a lot of people don't know what pressure cookers are these days, but basically if we have any cylinder of compressed air, okay, what's happening in that is you have these air molecules with energy and they are hitting against the side of our container. That causes pressure on the container. If you decrease the volume of that container, you're increasing the pressure because there's less space for them to move. They're going to be hitting the sides more often. Okay, so atmospheric pressure, yeah, the closer you are to sea level, the higher the pressure on your body. Okay, as you go below sea level, pressure increases even more. Eventually, it can get pretty dangerous. Okay, it's interesting and I think important to know that we have gases in our bodies. Okay, and when we go underwater, those gases are going to get compressed because we're not letting them out. Okay, so the capacity of your lungs while you're breathing underwater decreases, and you'll find that you only take smaller breaths the further down you go because your lung capacity isn't as big as it usually is on top of the air or on top of the water. Okay, and what can also happen is you can get air bubbles in, let's say, a tooth, and your tooth isn't designed to hold in air. So sometimes you have these divers that go deep underwater and their tooth explodes because of that air trying to be released. Okay, so when we're looking at upthrust and flotation, we also have to consider density. Now, upthrust is the upward pushing of the water on an object when that object displaces a certain amount of water because of its volume. Okay, so an object will float when the upthrust is equal to the force pushing the object down, gravity. Okay. Now, depending on how much upthrust there will be, depends on the mass of the object as well. The heavier the object, the more it's going to be pulled down, the greater the upthrust. If it is being pulled down at a greater amount than the upthrust, okay, then it will sink. Now, this can change depending on the density of the liquid, okay? So salt water is a lot more buoyant than fresh water, okay, because of the salt inside of it. Mercury is extremely dense. You can float a metal hammer on top of mercury, okay? And the calculation that we use to calculate for density is m divided by v, okay? And that makes, because as your mass increases, your density is going to increase. Okay, but as your volume increases, your density is going to decrease. This is why ships a lot of the time are not facing upright, right? They don't sail just like this. They'll have a very broad, flat bottom. Okay, and that's to increase the volume of displaced water as much as possible, to increase the volume of the ship as much as possible, so there's as much upthrust as possible, and this is going to allow them to increase their mass, okay, so they can carry more without sinking. So an object denser than the liquid will sink because the weight exceeds the upthrust. Okay, an object less dense is going to float. The upthrust on an object in a fluid is in an upward force due to the fluid's pressure. Again, so that fluid is going to be hitting, those particles are going to be hitting the bottom of that boat. That is upthrust. Okay, if you are going to decrease the amount of space those liquid particles have to move, they're going to push up even harder. Okay, and the pressure at the point in a fluid depends on the fluid's density and the depth, as we were talking about earlier. Okay, so my name's Cameron. I hope this made sense. Try some examples. Go look around you for, pressure. Okay, where can you see pressure around you? Where is something's area a certain size so that there's increased or decreased pressure? Look for density. Okay, go look at the shape of boats' bottoms. Okay, go look at different boats. Why are some of them pointed while others are flat? Okay, have a look at it. Science is all around you. So yeah, my name's Cameron, and I'll see you next time.